Okay, so we're going to talk about things that we know about the centroid. This is going to be similar to the last video, except for this one is going to be all about the centroid. And just like last time, it's really important that we first of all know what it's made from. So the centroid is the point of concurrency that's made from the intersection of all of the medians. So medians, in order for us to know what their intersection will be, we first of all have to define what a median is. And a median is the segment that connects the vertex to the opposite midpoint. So what that tells you is that each side will be bisected. So each side of the triangle will be bisected because that midpoint is involved. Now, the centroid has a special property, and it creates two formulas for us. The centroids are all, they take a median, if this is our median, and let's say that this is our vertex and our midpoint. Then our centroid is going to divide this up into a short part and a long part. So once that happens, we have two formulas that are going to come in handy as we continue with our lesson here. And that is that the short will always be the length of the whole cut into three parts. Because technically there are three parts in here, it's just that two of them together are on the long side. So that also tells you that the long is 2 times the short. So for example, if you knew that the short was 2, then you could say that the long is 2 times 2, or 4. Or in another example, if I told you that the whole thing was 9, then you could take 9 divided by 3 to get the short, and then multiply that 3 by 2 to get the long. Okay, so pretty simple. These are the two big formulas that we need to remember for the centroid. Okay, so the next part that we're going to talk about here is solving for variables in the centroid. So if we have, if we know that Q here is the centroid, there's a few things that we know. The first thing is that since the centroid connects midpoints to vertices, our vertices of this triangle are F, E, and D, that means that N, L, and M must be the midpoints. So that means that EN and ND are congruent, as well as LD and FL, and also FM and EM. And that's the first thing that we know. And just for reference, I'm going to go ahead and write down our formulas that we talked about on the last page. So that would be that the short is the whole divided by 3, and that the long is 2 times the short. So looking at the first one, it says that EL, if we find EL in our picture, that's talking about a whole median. So EL is a whole. And that whole is 5x minus 4. And the other piece that we're given is QL. And QL is a short. And conveniently, we have a formula that uses a short and a whole. So we're going to write that down. We're going to say that the short is equal to the whole divided by 3. Well, our short is 3. The whole is 5x minus 4. And we need to be dividing it by 3. So the next thing that we need to do, if we need to get rid of a divide by 3, we're going to do the opposite operation and multiply by 3 on both sides. When we do that, we get that 5x minus 4 is equal to 9. Adding 4 to both sides is going to give us 13. And dividing both sides by 5 is going to give us 13 over 5. And we're going to leave it like that. And then we've completed this problem. It just asks us to solve for x, and we've done that. So the next thing that we need to do is look at number 2. It says that ED, so we look at our picture and we find segment ED is 12. And it says that we need to find ND. Well, ND is one of the two congruent parts of this segment because N is a midpoint. So if N is a midpoint, that means that if the whole thing is 12, each of these should be 6. So ND is 6. And we had to do very little to find that. And for the last segment that we're given, it says that QF is 3y minus 5, and QN is 5y minus 27. Now QF here is a long segment, and QN is a short. So we're going to use the formula that says long is 2 times the short. So our long segment is 3y minus 5, and our short segment is 5y minus 27. And when we work this out, we have 3y minus 5 equals 10y minus 27 times 2, which is 54. And so we continue to work out this problem, and we could add 54 to both sides and also subtract 3y. So that's going to leave us with 49 and 7y. So y is equal to 7. So it didn't tell us what to solve for here. So we have y equals 7, but let's go ahead and figure out what qn and qf would be. So we plug in our 7 for qn, and we have 35 minus 27. If we do 35 minus 27, we're going to get 8. And that's for the short side. So the long side, without even having to plug this in, it should be equal to 2 times the short side, or 16. If we plug it in just to check, we can say 3 times 8, whoops, not 8, 7, because that's what our y is. So 3 times 7 minus 5. 21 minus 5, sure enough, is 16. So we're going to move on to the last thing that we're going to talk about for the centroid, and that is how to find the coordinates of the centroid. And for this one, we're going to start in the same way that we did when we looked for the circumcenter. So we go to the point 10, 4, and we plot it. And that's point A. We do the same thing for points B and C. So we go to -6, -4 for point B. And point C we can find at -4, +6. And we're still going to connect these to make our triangle. So again, in order to find the coordinates of the centroid, we have to know that the centroid is made from a median. And it's the intersection of all of the medians. And medians connect a midpoint to a vertex. And to find the midpoint, we just have to remember it's the average x value followed by the average y value. So in these problems, we're not going to need to know the slopes of our lines. So we choose a side to start with. It doesn't matter which side. Let's say that we started with segment AC, and you needed to find the midpoint of this side. Well, the coordinates for point A are 10, 4, and the coordinates for point C are -4, +6. So to find the average x value, we're simply going to take -4 and 10, add them and divide by 2, and similarly 6 and 4, and divide them by 2. So our midpoint for AC is going to be 6 over 2, which is 3, and 10 over 2, which is 5. So we're going to go to the point 3, 5, plot it. We can call that point M for midpoint. And then it says that we need to take that midpoint and connect it to a vertex. Well, as you can see, M is already attached to A and C. So the only vertex that's not yet touching is B. So we're going to connect it to point B. But we need to have at least 2 medians. So we're going to repeat the process for another one of our sides. And let's say that we chose the side CB. So B was the point -6, -4. So for BC, our midpoint is going to be the average x value followed by the average, I guess we should keep these in the same order, followed by the average y value. So we'll have -10/2, which is -5, followed by 2/2, which is 1. And we can call that point N. So here would be point N. And we need to connect point N, which is a midpoint, to a vertex. It's already touching vertices C and B. So the only vertex that we aren't yet connected to is A. So we take point N and connect it to point A. And we can see that an intersection has already happened. But just to make sure that we've done everything correct, we'll go ahead and do the same process with the third side. So we haven't yet done the segment AB. So we'll find the midpoint of this by doing 10 plus -6/2 and 4 plus -4/2. So our midpoint for this will be 4/2, which is 2, and 0/2, which is 0. And we can call this point P. So we go to the point 2, 0, label it P, and connect it to the vertex it's not yet touching. And the vertex that we are not yet touching is C. And we can see that all 3 of our medians did intersect here at this one point, which is going to be your centroid. And the coordinates of the centroid, in our case, the x value is 0, and the y value is 2. So our centroid occurs at 0, 2 for triangle ABC.